Chapter 5, Electrons in Atoms. What is the quantum theory and what does it have to do with the atom? During electromagnetic radiation, the energy increases when the frequency increases. An electromagnetic wave consists of oscillating electric and magnetic fields. The two fields oscillate at right angles to one another. For example, if the electric field oscillates up and down, the magnetic field oscillates from side to side. Both the electric and magnetic fields oscillate at right angles to the direction of propagation of the electromagnetic waves. The temperature of an object is a measure of the average kinetic energy of its particles. As the object becomes hotter, it emits light at higher frequencies and therefore different colors. Photoelectric effect is the phenomenon of electron emission from the surface of metals in the presence of light whose frequency is at or above a certain value. When excited, atoms return to their ground state by emitting light, which corresponds to a certain transition of electrons between orbitals. The lines in the emission spectrum of an element correspond to the transitions. When electrons return to their ground state from an excited state, the atoms emit photon whose frequency corresponds to the energy difference between the two energy levels. Each frequency corresponds to a certain color. The Hinesburg uncertainty principle states that it is not possible to know precisely the velocity and the position of a particle at the same time. Bohr's model and the quantum mechanical model both limit an electron's energy to certain values. Unlike the Bohr model, the quantum mechanical model makes no attempt to describe the electron's path around the nucleus. In an atom, electrons are located around the nucleus at a position that can be described only by a probability map. A boundary surface is chosen to contain the region that the electron can be expected to occupy 90% of the time. The number of energy sublevels in a principal energy level increases as n increases. S orbitals are spherical and p orbitals are dumbbell-shaped. Higher energy levels are associated with larger volumes, which can contain more orbitals than the smaller volumes. It is reasonable, therefore, that more electrons can be contained in the greater number of orbitals associated with higher energy levels. The Aufbau principle states that each electron occupies the lowest energy orbital available. The Pauli exclusion principle states that a maximum of 2 electrons can occupy a single atomic orbital. Hund's rule states that single electrons with the same spin must occupy each equal energy orbital before additional electrons with opposite spin can occupy the same orbital. From this information, we can conclude that the quantum theory explains the nature and behavior of matter and energy on the atomic and subatomic level. The quantum theory also describes matter as acting both as a particle and as a wave. Electrons in atoms behave like waves. They exist as a fuzzy cloud of negative charge around the nucleus instead of as particles located at a single point.